Okay. So projectile motion. So when we say 2D motion, projectile motion is a great example of 2D motion. In which way? See, projectile means something is actually moving in upward direction as well as in forward also. Currently, like if I see this type of thing, you see this flow of water, isn't it? The fountains that are actually inclining at a direction, inclining upward also, and it is getting transferred to this direction. So it is not only just upward, it is also sideways also. So that means upward is one dimension and sideways another dimension. So two-dimensional motion, and the projectile is a great example of it. And we can see everywhere in fountains. You can see it is a real life example. Even if you are throwing something, even somebody throwing, even somebody firing something, all these things, even catapult, all these things are coming under projectile motion. All these things are coming under projectile motion. You see, somebody is standing on, some height. Is some height, at a some height. Somebody is standing on some height, let's suppose h, and he is throwing something. Two conditions are there. He can directly, he will not push something, he just throw normally, just uh, as it is, he just not throw something directly as it is, it will fall like this. Then it will be just 1D motion, that what we have no motion under gravity. But when it is like this, when it is like this, like a parabolic path, you see, at that time, suppose it thrown at a velocity u, therefore it thrown at a velocity u means not like that. It is something, some angle, with some angle. See, with some angle, with some angle. So with some angle, with which axis? If you consider this is an axis, then this is the angle. So this is x-axis actually, and this is your y-axis in opposite direction. No problem. Negative y, no problem. So that means every time you will have these two component of velocity. One is actually, if you consider u, that is ux, and that is uy. Every time, every time. Now the thing is that the component of velocity along x-axis that will not change. Will not change because these things are like uniform velocity. For x component, it is uniform velocity, but for y component, as it is influenced by gravity, it will get increased. So it will constantly change. It will change. It will increase, but this will remain just as it is. As it is. The same concept, like if I throw something in this way from the ground, and if it is attaining a height and then finally coming to a point, at that point attaining a height, finally coming to a point, at that time also it do have two component, because you are throwing in this direction now. So always is, it has two component. One is ux, another is uy. Us is nothing but, if it is u means u cos theta, and this will be u sin theta. And that time you are basically stating me na Latika ke it will never happen, the velocity at the top will not be zero. Here in this case you can justify it, because at the top position what will happen, because this x component will be same, because it is not under any acceleration. Only the y component, as it is going up against the gravity, so it will reduce because the y component, this y component of velocity is under retardation, because it is against the gravity. So what will happen at the top position? Its uy will become 0, but still it has ux. So therefore, that is true in projectile case. And it is very tough to maintain something directly straight, go straight away and come down. So generally we can say normal, if you throw something at a highest altitude, its y component becomes 0, but still there is x component. So altogether its velocity can't be 0. Clear? Clear about this?
Yes, sir.
Yes, sir.
Okay. Now moving to the this thing, like what I have shown you. A football is actually kicked by this way, and this is something like, if you consider this is the velocity vector, like initial, that is why 0. Okay, and it makes theta angle. So definitely what I was saying, like this is the y component, this thing upward direction is always y. So initial value with sine theta, and this is x component, initial value with cos theta. Now here also, when a cannon is fired, this cannonball, it also have the same thing. Okay, and here you can see that animation, how this y component is getting 0, still there is an x component. Again reverse, y component 0 to it is getting increased, but x component, you see the length of this vx. Again, if you miss it, again see this vx, the blue color thing arrow, it remains same, whereas the vy green color, it is reducing. Okay, so the altogether velocity is there. Again, when it is coming down, vy gradually increasing, vx is remain constant, and you can see the maximum height hm denoted by hm. So this is a clear example how the projectile motion will occur, and how these components of velocity, at first it getting decreases, there is vy, but vx remain constant, but at the second half opposite thing will happen. Okay, now we'll see the component of the velocity. One is the horizontal component, that is cos theta, v naught. You can consider it, it can be considered u also. U, if you consider initial velocity to be u, so u cos theta, or you can consider v naught also initial. Then vertical, v naught sin theta. And now what actually I was telling, see, for the, what we'll do for horizontal distance to be covered, you know the formula. Sx means horizontal distance, is equal to ux, that means the x component of the velocity into t, plus half ax t square. But the thing is that, what I consider, in horizontal distance, does it have any kind of acceleration? Hmm? Does it have any kind of acceleration in
No, sir.
horizontal distance?
No, sir.
No.
No, sir.
Therefore, this thing getting 0, only it will have Sx is equal to uxt or vx, whatever you are considering the part, that means it will be uniform velocity. Uniform velocity means distance is equal to speed into, sorry, velocity into time, that formula. So this is due to, this is the horizontal distance covered, but in case of vertical distance to be covered, what will happen? So this is what actually, in terms of vector, we can write ux is actually, if you consider v naught to be the initial velocity, so v naught cos theta, actually this should be not down, subscript v naught cos theta t, and other components to be 0. Okay, now vertical distance. So vertical distance is something there you can basically apply that concept, because if it is having the acceleration, because in vertical distance it should be, why they have not considered any kind of, no, vertical distance to be covered v naught sine theta into t, but you should consider that component also with it. Here you should have like minus, because it is upward direction and gravity is downward, so minus half gt square, that has to be there for y axis. For y, that distance should be in that way. Okay, it should not be like that, this should be added. And horizontal component of velocity at time t, horizontal component of velocity, as this acceleration is not there, so horizontal component will be always v naught cos theta. It will not change, it will not change. Horizontal component of velocity is independent of time, as the acceleration in x direction is 0. But if you consider the vertical component of velocity, then it will be v is equal to u plus at, that thing. So actually it is vx, what they have written, vx is equal to u suffix x, sorry, subscript x plus a subscript y t. So this could be y, actually this could be y, because this in vertical component, so y, you just limit as y. So what it will you will get vy, which is nothing but any this vy at any time, suppose at any time will be initial, that is v naught sine theta, then minus g, and then t. Okay, okay, so actually this should be changed, see, vy, okay. So vertical component of velocity is time dependent. Because why it is time dependent? Because it is under the acceleration, that's why it is time dependent. Equation of the path of the projectile, that is very important. For horizontal it should be horizontal distance, what distance is equal to velocity into time, as it doesn't have any acceleration, so velocity at horizontal v naught cos theta into time. For vertical, y is equal to uy into t. Okay, actually this has some mistake, just a second, let me modify it. Here this should be here, okay, minus half into gt square. So y is actually v naught sine theta into t minus half gt square. Okay, now you can basically do one thing. What type of thing you can do? Like, see, from the first equation you can get the time, x is equal to v naught cos theta into t. So from that, because time will be the same now, with the same time you can, this time if you get the value of time you can replace here. So time is x by v naught cos theta. Therefore v naught sine theta, if you replace this value, suppose this is equation 1, if you replace it over here, x divided by v naught cos theta minus half g. Now this t square means x divided by v naught cos theta whole square. Now what will happen? V naught get cancelled. Sine theta by cos theta is nothing but tan theta. x tan theta minus half g x square, then v naught square cos square theta. And that can be changed, like if you just do it, 1 by cos theta is nothing but sec na unibo, 1 by cos theta.
Yes, sir. Sec theta.
Now you see gx square by v naught square, and this is sec square theta. Now sec square theta is equal to 1 plus
1 plus tan square theta.
that you can do half into g x square by v naught square 1 plus tan square theta. This is the equation of path of projectile. Any doubt, Latika? Oishi?
No, sir.
No, sir.
Clear about this? This derivation is very important. Okay. So you must remember when we consider x-axis, all these things, no acceleration, y-axis, always the acceleration, that is g. And component along x-axis of the velocity will be the cos component, and y-axis will be the sine component. That is what we are considering over here. Shall I move to the next?
Yes, sir.
Now, actually, these things actually calculated whatever I was doing. That thing they have done. Okay. Now the maximum height. It is very much important. Let me do it by comparing whatever we have done in motion under gravity. See, you don't need to remember the thing separately. Just try to think in a connecting way. Find the missing link between the topics. Like if it is motion under gravity, what we know we know the maximum height. First, you know, for motion under gravity, something going up. So at a certain height, maximum height, the velocity becomes zero, because now you know this velocity is nothing but the y-axis velocity. So it always becomes zero at maximum height. But x-axis velocity is there. But as you are throwing it just up, so there is no x component, y component. So y is become zero. So if I want to get the maximum height, so v square is equal to u square minus 2gh. So v square becomes 0. So u square is equal to 2gh, or h is equal to u square by 2g. That is there. That is for only motion under gravity. Now, if you consider this for a projectile motion, so for a projectile motion, your v that thing becomes zero. If you consider y-axis, the vy, that thing becomes zero, no problem. But u is actually, you can consider u square means u square sine square theta, yes or no? Because y-axis minus 2gh. So h is equal to u square sine square theta by 2g. Correct?
Yes, sir.
Now just compare this thing with this. What happens in case of projectile? Projectile means you should have some angle with this. But what happened motion under gravity? Directly this angle is nothing but 90 degrees straight. So sine 90 is 1. So that is why here you have only u square by 2g. But here u square sine square theta by 2g. Clear?
Yes, sir.
Clear, Latika?
Yes, sir.
Now you see, for time to reach the maximum height, for normal, this condition 1D, for normal, you know, for reaching the maximum height, t is equal to u by g. And total time, if you take, that is u by g plus u by g to u by g. Here also it will be for maximum height you will be u, but it will be u sine theta by g. And then total time of flight of this total projectile will be 2u sine theta by g. That is the thing, not more than anything. This is the basic concept. So time to reach the maximum height would be this for projectile. Again the same concept here, sine theta sine 90. If you put sine 90, so you'll get for direct this 1D motion. So 1D 2D is nothing but they have some relation in between them. Now, so that what they have done. Now the time of flight also this thing. Okay. Now the horizontal range. For getting horizontal range, we know something like we should take the time of flight total time of flight t for projectile, it is 2u sine theta by g, because you need total time. And as horizontal range, if you take as r, or distance is equal to velocity into time. Velocity is u cos theta, because u cos component na, and time is 2u sine theta by g. Now if you compare or combine both of them, so 2u square sine theta cos theta by g. Now you see this thing, u square, you keep it like this, 2 sine theta cos theta, formula is
Sine 2h.
sine 2 theta, u square sine 2 theta by g. This is the range
Sir,
formula.
can you please explain again the range part?
Range part na, range means the x-axis, not the y-axis.
Yes, sir.
X-axis means what? Uniform velocity, no acceleration. So for uniform velocity, what is our formula? Distance is equal to velocity into time. So here range is equal to velocity into time. Velocity means x-axis velocity into time is this. Time is total time. Total time once it go up and come down, because range will be the total thing na. This is the range. Range means horizontal distance. So u square and this 2 sine theta cos theta is sine 2 theta by g. Clear?
Yes, sir.
Okay, this is how they have done it. So r, this is a concept, r is maximum when the sine 2 theta na is maximum. So sine 2 theta maximum means sine 2 theta maximum means sine, what is the maximum value of sine? That one, so that means sine 90.
90 degree.
That means 2 theta is equal to 90. So theta is equal to 45.
45.
So at 45 degree, you will be having maximum range. Correct? You will be having maximum range. So the maximum horizontal range. So that thing. So maximum horizontal theta 45 degree. So you sine 90 means v square by g. V naught square means initial velocity. That's all by g. That condition. Okay. Now see this question. At what initial speed must the basketball player throw the ball at 55 above the horizontal to make the shot as shown in the figure below? The basketball rim is 18 inches they have given in diameter. Other data are given in the figure. So other things like 7 feet, in feet and inches they have given, and that is 10 feet. So you should give it in that way also. Don't need to change it. So 14 feet is actually the you can say it is the distance from where the person is standing and the basket is there, and then it has basically at a height of 7 feet it has thrown. So it is the point of projection. You see from here it is basically projected. Okay, from here it is projected. Okay, so this type of problem can be given. This is an applied type of problem. So what we should do? See this thing. First thing is that it has been projected from this point, so 7 feet from the ground. And if I consider v naught to be the initial velocity and theta is given 55 degrees, so v naught cos theta is the vx and v naught sin theta is the vy. And 14 feet and 10 feet is the height where it should be basically it is the point of the basket is there, 10 feet. So effective horizontal distance is what you should consider. Effective horizontal distance. See, first thing, here you can see these two arrows are given and here 1 feet is written. What does it mean? That means these distance, a small distance you can see now, this is 1 feet. That means the ball is not thrown from where the person is standing, but from this point, which is actually 1 feet from this 14. So the effective horizontal distance will be 14 minus 1. Why? Because you see 14 is, if you see this thing, 14 is where his feet is there, but his hand is 1 feet away. You understand? So
Yes.
therefore effective horizontal distance is 13 feet, not 14 feet. Because you should consider from where the ball is being thrown, na? And at the same time, effective vertical height also can be changed, because you see 10 and 7 is there, na? Okay. So that is 3 feet. Effective vertical distance, 3 feet. Because you have to see from where the ball is getting thrown. So that is basically known as point of projection. Always, whenever a problem is given, look for point of projection. Don't look for other thing. Point of projection. So your point of projection is very much important. Somebody is throwing it from a certain height means which one is been thrown, that. So you should consider the initial coordinate of it. So actually it is thrown with respect to this basket and all this thing, it is thrown at this elevation. So the basket is 3 feet away from it. And this distance is actually 13 feet. This is the first thing you should consider. Now all this angle and I have taken all these things, and this is
Sir.
horizontal. Yes.
सर अभी मेरा एक क्लास है 3 बजे से.
Okay, you can leave. Okay, I'm recording this. Okay.
Yes sir.
Okay. Now Vx is V naught cos theta, Vy is V naught sin theta. Now if you see the time taken by the ball to reach the basket, why I have taken this? Because it is very good way, because I have taken the vertical, not horizontal component. Why? For horizontal component, Vx velocity is equal to distance by time, because no acceleration. So time is equal to 13 by Vx. Okay. And if you substitute the Vx is V naught cos theta, you substitute it. Okay. And then what in terms of vertical thing, what you consider, the height was 3 feet. So 3 is equal to Vyt minus half gt square. Now the time you got it already, this. Okay, this 13 by Vx. If you substitute that thing, you will be getting what you will be getting. You will be getting like this. See, 3 is for y, this is for your Vy, and this is for the time. Actually, time is actually distance by this Vx minus half g distance by this. So actually this is the equation of trajectory. What we have proved, that thing we are using over here. So you can use that tan thing, and that one is actually the sec square theta. We know it already. Okay. you can basically then form a equation like this thing is actually they have missed it. It will be v square. So v naught square. So square first you will get, and then you need to do the square root of it. Okay, because from here, if you see this thing, if you rearrange it, it will be half. I am keeping this g over here, so g upside, and this 169 was there. Sorry, they are there divided by 13. Okay, so 169 was there divided by 13. Now you see if t square was upside, and if you divide it with ft, tan also here, tan theta, minus 3 ft. Minus 3 ft. So therefore, that will be your v naught square. Okay, v naught square. Oh, here I forgot one thing. It should be there like this cos square theta, that will be there, na? This cos square theta is there. So you can consider common cos square theta, that is equal to v naught square. So v naught is equal to square root of this thing. You can cancel out this thing also. 13s are 169 ft na ff, feet, this feet ft, this feet is, so no need to give this feet and all this thing. Now this will create problem. Just replace these things, this ft all these things. Now no need to give all these things. You just give one thing like here 169 it was there, and then half g, keep it like that, and then a 13. Okay, and then 10 minus 3, and then cos square theta. That's all. That's all. So 169 into, if you do that thing also, directly you cannot cut it. Minus 3, na? You directly cannot cut it. So g value you can replace with 10. If they have not given, then 9.8. And then that will be your v naught square. So v naught is equal to the square root of that thing. 169 again, you will be getting 13. Below part you need to do. You just put the value of theta 55, it is given. But we don't know, oh, v actually v naught we need to basically figure it out. Other things are given. So 169 into this, g na, it is in feet is given. So 32.2 feet per second square. If given in British scale, 32.2 in feet, because we have not changed feet to anything. 32.2, other things are all done. So it will be like this, 23 feet per second. Keep it like this if it is given in this way. Generally you will not have this feet and second. Generally in SI unit they will give. Sometimes they can give, but then they have to mention it. They will mention the g value 32.2 na. Don't worry about it, they will give it. Okay, so that's all for